Welcome to This Explainer. Today, we're diving headfirst into a wild, suspenseful thought experiment, the 10-second oxygen blackout. Just imagine you're sitting exactly where you are right now. Everything is totally normal, completely fine. And then, out of nowhere, the impossible happens. Every single molecule of oxygen around you simply vanishes. 10, 9, 8. The clock starts ticking immediately. Put yourself in that room for a second. What happens to your breathing? What's going on in your brain? What happens to that candle burning on your desk? And maybe the most terrifying question of all, what happens to your body when that countdown finally hits 0? Section, what is oxygen anyway? Let's start by figuring out what exactly just disappeared from your room. Okay, so oxygen. It's this invisible, life-sustaining gas naturally present in Earth's atmosphere. Because we literally can't see it, and it's always just there, it's something we rarely ever think about, right? We just automatically expect our next breath to be full of it. But it's actually the anchor of this massive, intricate oxygen web. I mean, think about it. Human respiration, animal life, the natural cycles of plants, even fire and combustion. All of these completely different systems rely entirely on this one single element. If you pull that thread, the whole web collapses. Section, the experiment begins. Let's set the baseline for our 10-second countdown. Look at this stark contrast. We are going from a completely normal room, abundant oxygen, a candle burning, you've got a clear head and normal breathing, straight into our experiment room. Now, here's a really important distinction. Removing the oxygen does not mean the room becomes a literal vacuum. The other atmospheric gases, like nitrogen, are still there. The air still physically exists around you, it's just missing that one magic ingredient keeping you alive. Section, the first few seconds. The clock is officially ticking. Let's watch what happens to that burning candle. Step 1, the oxygen vanishes from the air. Step 2, without that oxygen to fuel the chemical reaction, combustion just halts. It hits a brick wall. And step 3, the flame dies. It doesn't flicker, it doesn't slowly fade out. It instantly disappears because its fuel is literally stripped away. Which brings us to a pretty profound question. If a roaring fire cannot survive even a single second without oxygen, what on earth happens to the human body? Section, inside the human body. Let's look under the hood at how your internal systems react as that clock keeps ticking. The reaction inside you is immediate. You try to take a breath, but suddenly your lungs cannot extract any useful oxygen from the air you're pulling in. Because of this, your blood just stops carrying fresh oxygen to the rest of your body. And your brain, which is incredibly sensitive and demands a constant supply of the stuff, detects this extreme shortage almost instantly. This triggers rapid distress, confusion, and some pretty intense dizziness. But wait, here is the crucial difference between you and that candle flame. 10 seconds of oxygen loss does not equal instant death. The human body does not instantly stop working like a switch being flipped. You actually have small reserves of oxygen floating around in your blood, giving you a tiny buffer before your systems completely fail. Would you pass out? Let's look at a major mystery of this whole scenario. Well, as this quote points out, the exact response really depends on the person's condition and the speed of the oxygen loss. We can't guarantee a one-size-fits-all survival timeline. Depending on your physical fitness and your lung capacity, a 10-second blackout might just leave you feeling incredibly dizzy. Mostly because 10 seconds is actually relatively short compared to prolonged oxygen deprivation. Tracking our timeline here, you can see how fast things escalate. At just 1 second, confusion sets in. By 5 seconds, the flame is dead and normal breathing is completely impossible. And right at the 10-second mark, boom, you hit a critical biological threshold. Your brain is practically screaming for air. Section, then the oxygen returns. The clock finally hits 0. Whoosh, the relief is instantaneous. Normal air is restored to the room, your panicked breathing regulates as your lungs finally grab what they need, and your body gets its lifeline back. And this is kind of crazy. If there was still a hot enough ember left on the wick, that dead candle could actually reignite entirely on its own. But a quick reality check here. Returning oxygen does not magically erase any injury that might have occurred from the deprivation. Shocking your brain and organs by starving them even for just 10 seconds is a massive biological blow to the system. Section, what if it lasted longer? Let's explore the terrifying idea of that clock not stopping at 10. Look at how this risk scales up on the table. At 10 seconds, the danger to your body is moderate, mostly just confusion. But push that to 30 seconds, the risk level becomes high. meaning severe dizziness or just straight up going unconscious. And if you push it to several minutes, you hit severe danger, with potential for permanent organ damage. This is exactly why this remains strictly a thought experiment that no one should ever try in real life. Section, the big lesson. We made it through the 10 seconds, so what's the ultimate takeaway? Oxygen seems so invisible and ordinary, but it is absolutely essential to the way humans live. We usually feel completely safe in our homes, right? We never give a second thought to the air around us. But remove just one invisible element, and an ordinary, comfortable room suddenly transforms into an alien, incredibly hostile place. So, I'll leave you with this final, provocative thought. If something you literally cannot even see is this vital to your very existence, what would you check first if the oxygen in your room suddenly disappeared? Think about how deeply we depend on the invisible world around us. Thanks for tuning into this explainer, and keep questioning the science of the world around you.